Hello, you've come back. Thank you very much. This is the second of the talks on retro philosophy, and if you remember last time we were looking at a difference between philosophy, which starts with a truth and then uses as a construct, and retro philosophy, which starts off with what we know and via a narrative builds to a new truth. Now then, what I want to do in this second talk is start to expand on the differences between the two. And really, the big difference is that philosophy tends to use words, whereas retro philosophy uses words and numbers. So let me just explain that a little bit. The great philosophers, on the whole, used logic and reason. They used words to develop their truth, and they constructed the argument in words. So this is their foundation, the truth expressed in words, and they ended up with words. With retro philosophy, we start off with what we know, and we've got 500 years of science now, and that science can be expressed in numbers. So what we know at the bottom is expressed in numbers. We then develop a narrative to come up with a new truth at the top, and that's in words. So we're starting to use all of language rather than just half of it. And a very simple example of that is what I think probably happened right in the beginning, at the dawn of consciousness. A lot is made of the fact that we started talking and came up with myths which helped us move from the Stone Age into this kind of civilization. Not quite so much that we, as other animals, have always been able to count using our fingers or what have you, and measure. And it was through this that we established the proof that there's order in this world. Order in the natural world and order in our own world. So it's not that surprising that, given the early myths of spirits, of animal spirits and ancestral spirits, once we'd shown that there was order, that order had to come from somewhere, and the spirits evolved through into gods. So that's quite a good early little example of retro philosophy. Now, unfortunately, a lot of this is taught very separately. At school, I did science in all the right silos, maths, pure maths, and physics, chemistry, biology. Never a word of philosophy was mentioned. And then, as for philosophy, well, I don't think I was taught any. I can't remember any. History, geography, no. English, no, not really. Reason and logic wasn't really part of the curriculum. And that left me unprepared for my shameful first day at college. And let me just explain this. Back in 76, the long hot summer of 76, first half on the beaches of the Gower, second half helping construct the M4 motorway at Port Talbot. By the time I got to college, I could hardly read or write. I was semi-savage, didn't really know what was going on. But I knew I could do this science stuff. So I want to tell you about my first day at college, because I had 3 lectures and was left bewildered by them all. First of all was physics. Now, physics is easy. Every little bit has an equation. You apply the equation, off you go. I wandered along, and some geezer drove a Rolls Royce into a matchbox. That's what I remember. I thought, what's going on here? It was ridiculous. Anyway, next lecture was chemistry. Chemistry, yes, so they get a formula, A plus B gives you C, or 2 C's or whatever. I thought, that's not going to be a problem. The next thing I knew, they were showing atoms with big bubbles coming out of them. I'm thinking, what is this? I've never heard of anything like it in all my life. And then my third lecture was on a thing called crystalline materials, and what that was trying to do was show how to represent a 3D crystal, take a photograph of it with X-rays, which is 2 dimensions, and how you interpret the two-dimensional photo into a 3-dimensional crystal. And unfortunately for me, I'm not born with that spatial awareness that most blokes are, and so I just couldn't do it. Anyway, the consequences were disastrous. So shame on the family. Mum, I'm sorry. But anyway, a couple of years later, I had to go back and teach this stuff. And when you have to teach it, you start thinking of it very differently. So you need to find out what's going on. So let's take the physics. In the physics, because it was relativity where they drove a Rolls Royce into a matchbox, we think of speed being relative. If you're on a station and the train goes about 1 mile an hour, that's fine. If you're on that train and another train goes in the opposite direction and it's also going at 1 mile an hour, you add the two together and the relative speed is 2 miles an hour. So speed is relative, time is not, because time's the same for everybody. Anyway, in physics, a guy called Maxwell came up with his theories, electromagnetism, and realized that the speed of light was the maximum speed that anything could go to. So there was a limit to how fast things could go. And a couple of decades later, it took old Einstein with a thought experiment to imagine what it would be like on a train going towards the speed of light when another train goes past also nearly at the speed of light. Because what you couldn't do was add those two speeds together, because that would be a lot more than the speed of light. So speed wasn't relative. So if speed wasn't relative, well, something had to give. And that giving was time. It's time that's relative. And suddenly all the maths works out with his new equation, and we can look at the movements of big objects and it all fits with Einstein's equations. Well, that's for the chemistry, which is really, they were looking at the chemistry of small things. We're starting to move into the area of quantum mechanics. And quantum mechanics basically gives up some contradictory results. If you're looking at electrons, they behave both as a particle and they behave as a wave. And they can't really do both, but they do. If you start trying to observe them, you get into all sorts of philosophical conundrums and cats, and being off to see plays called Copenhagen about the philosophy all behind it. But they did hard philosophy. Excuse me. When it came to teaching it, it was a little bit simpler. I said, look kids, we're going to think sometimes it acts like a particle. So this bit of Schrodinger's equation shows it as a particle, and sometimes it acts as a wave. And oh, look, this bit of Schrodinger's equation is the wave bit. You put the two together and you come up with a formula that works. We don't really understand why. Philosophy got us there, but we've now got a new formula that works and explains the micro quantum world. That was quantum mechanics. And then the third one was crystalline materials, if you remember, and I just couldn't do the spatial awareness. And neither could Rosalind Franklin, and she was the lady that brilliant lady that first came up with an X-ray photograph of the structure of DNA. She got a photograph, and if she had then laboriously gone through and mapped everything, she would eventually come up with a structure. Unfortunately for her, a couple of chancellors, Crick and Watson, came in, managed to talk her into showing this photograph, and immediately realised, looking at the points on the photograph, that this was a double helix. They were able to turn the mathematical photograph into words, into the helix. So there you are. And what then happened with all of those theories is that they were able to test them out, and they've all been remarkably successful in explaining the world that we lived in. So you started off with a measurement, you came up with a philosophy, and then you got a new truth and a new science, yes? And that's what I'm hoping for retro philosophy, that basically if we start off with the science, with the numbers, with the maths, we do new narratives to come up with new truths and new science, we'll see the world in a different light. I think that's enough for a second lecture. In the third lecture, we'll move on again. But for now, there's a plane going over. Bye-bye.